Robot, sorted array, lockers, searching with binary search for a value I want, and that value is Z, hoping that it's in the array of lockers, but it's an array of letters of the alphabet, strings. I will first look halfway between index 0, the first index, and index 5, which is the last index. This is index 2 that I'll look at first. The value at index 2 is E. E is less than the value I'm looking for, because the value I'm looking for is Z, and E is less than Z in the alphabet. So I know the value must be to the right in the array. It can be between index 3 and index 5. I will look halfway between index 3 and index 5, and that's index 4. The value at index 4 is S. S is less than Z. My value must be to the right, which means that my value is at index 5, as we see. It's C. I checked. And I will return the index that Z was in, and that's 5. Good thing Z was in the array, or else I would have returned not an array or an error message or something. Robot, Sally. Selection sort and binary search. I'm using array of blockers. First, I will pass through all of these in the array and see what the smallest, or first in the alphabet value is. Finding the smallest value. That's an S. S is currently the smallest value. That's an F. F is now the smallest value. C, or A. Smallest value is A. C, Z, not smaller than A. A is still the smallest value in the array of blockers. Integers, letters. C, not smaller than A. Okay. 5. E, not smaller than A. A is the smallest value. I will now go to index 2, which has A in it, and place that at index 0 and swap it with the value at index 0, which is, as we all know, it's S. At index 0, the value is A, and at index 2, the value is S, because I'm a robot. I will now look at the array of index 1 to index 5 and find the smallest value. F is currently the smallest value. S, not smaller than F. Z isn't smaller than F. I will now look at index 4.
I got one.
C, smaller than F. C is now the smallest value. Nope.
Not yet, not yet.
I'm not doing this yet. I'm also looking at index 5. Oh, E, not smaller than C. I will now place C, the smallest value, at index 1 and swap it with the value at index 1, which is F.
We are. I gotta get the birds.
Is that Alice?
Yeah, they're gonna bring them up.
No, it's Sally.
Literally.
Video. Bye, guys.
The first two indices are sorted. I will now look at the array from index 2 to index 5. S, smallest value so far. Z is not smaller than S. At index 4, I have F. That's the smallest so far. E is smaller than F. That is the smallest value. I will place the value of E at index 2. And swap it with the value that is currently at index 2, which is S. We'll go to index 5. I will now look at the array of lockers from index 3 to index 5 and find the smallest one. C, smallest value so far. Would you like to play a game? F, smallest value. F is smaller than Z. S, not smaller than F. F is the smallest value. Placing F, value of F, at index 3. yes, I am placing the value of f, which is in index 4, and I'm putting it at index 3 and swapping it with the value at index 3 because I am a robot. Now, looking at the array of lockers from index 4 to index 5 and finding the smallest value. You see, smallest so far as values go. S is smaller than Z. Swapping S and Z, putting S at index 4 and Z at index 5. The array of lockers is sorted from smallest letter to highest letter, as you can see from the outside of the lockers.